molecules, atoms to grams. All right, again, so we're starting with molecules, atoms, but in order to get all the way to grams, we first got to get to moles. Then we can get through our chemical reaction to the moles of whatever we're trying to convert to. And then we take that to grams so we can weigh it out. Okay? So, same quantity that we had in the last problem of molecules of carbon or copper oxide. And we're still going to carbon in CO2, it's just we want grams of the carbon in the CO2. Which means we're using this same first steps. So let's just copy those over. We're using these steps here to get to moles of our products, right? So I'm going to copy those steps over. I'm going to erase some of the parts that I don't need for this problem. Right? Let's rewrite this. Okay? So let's review what we did in the last part, just so that we're on track here. Remember, we started with the molecules. So we have this many molecules of copper oxide. We first need to get it to moles of copper oxide. That's this step. Once we've got it to moles, we're then converting from, oops, we need to balance our reaction. We're then converting from moles of copper oxide to moles of carbon for this one. That's the 2 to 1. And then moles of carbon dioxide for this one. That's the 2 to 1 there. All right, so that brings us to this stage. So now, instead of stopping, we're going to take it one more step. I'm going to do one more conversion. We've got to get it to grams of our substance, right? So if I'm going to take carbon to grams, and I'm going to take carbon dioxide to grams, I need their molar masses. Right? These are the same numbers we used in previous problems. So moles of carbon's got to go on bottom. Moles of CO2's got to go on bottom. And then grams of carbon on top. Grams of CO2 on top. Right? So we know this is 1. And I have them memorized now. 12.0111 grams is how many grams are in a mole of carbon. And this was 44.0099 grams of CO2 for every 1 mole. I just remember it because I just did it, right? But you'd have to add that up from the periodic table if it were a different problem, right? And now we can get our answer, which I'm going to have to squeeze in here somehow. Let's see if I can do this a different way. Move all this over. That was not what I wanted to do. I think this is what I want to do. Well, sort of. Let's try that. All right. Now, we'll do our math. So, it is 7.56 divided by 6.022 divided by 2 times 12.011, and that again is to 3 sig figs. This time we get 7.54, and again that is, we have to do our exponents. That's, we have a 23 here, so it's 24 minus 23, which equals 1. So that's times 10 to the 1. And to get we don't need to get rid of it since our decimal is in the right position, and that is grams of carbon. So that's how many grams of carbon we have. CO2 will be different since we now have a different molar mass. So it's 7.56 divided by 6.022 divided by 2 times 44.0099. This time I get 27.6, and it will be times 10 to the 1 again since it's the same situation. So what we have to do is take that decimal over to the left, which makes this larger, times 10 to the 2. So it ends up being 2.76 times 10 to the 2 grams of CO2. Now we know how many grams we have of each, so we can actually, again, more practically weigh it out.